Hi, my name is Steve Blyle and I'm a welder. Whether you're headed out to work in the welding industry or out to your home shop, the goal in welding is the same, putting two pieces of metal together so they stay together. There are many variations and options in joining metal, not only material thickness, weld position, or strength requirements, but also individual techniques and skill levels. Every weld joint is made one weld bead at a time, so let's review some of the basic fundamentals. Whether your welding machine is electric or portable, the power source will provide either alternating current or direct current to the electrode. Alternating current flows in both directions, creating an amperage lag. Certain welding rods have been designed with stabilizers in the flux to help maintain the arc through these lags. Direct current welding machines provide a steady flow of current in one direction. The direction of flow, called polarity, is determined by how the leads are connected to the welding machine. DC plus with electrode positive is the polarity typically used for shielded metal arc welding. All the common rods used for welding on carbon steel have characteristics that make them better suited for different situations. The fast freeze rods have a strong arc force that helps burn off surface impurities. A circular or side-to-side motion can be used to build up weld, or because of the light flux coating, these rods can be stepped to provide maximum penetration. In the vertical weld position, 6010 and 6011 can be run either uphill or downhill. These are good rods for tacking up weld joints, welding metal that is slightly rusted, filling gaps in poorly fit joints, and as a first pass for good penetration. The filler rods don't penetrate as deep, they build up weld. Stabilizers in the flux make 6013 one of the simplest rods to use. With a slightly heavier slag covering, try to keep the arc in the puddle. 6013 can also be run either up or down on vertical welds. For general purpose welding, 6013 produces a smoother finished weld bead. 7018 contains iron powder in the flux and low hydrogen characteristics. Except for directly under the arc, a heavy slag covers the entire weld puddle. Either running straight or with a side-to-side motion, the arc needs to be maintained on the leading edge of the puddle. In the vertical position, 7018 is run uphill. 7018 requires better rod control, but does provide the strongest welds for heavy stress situations and also the smoothest welds for ornamental type projects. Welding rods are available in different amounts, and it's a good idea to have both fast freeze and filler rods on hand. Cover yourself up. Wear some good gloves, a hat, keep clean lenses in your welding hood, and always wear safety glasses. Before you light the rod, get comfortable. Scratch to light the arc. Bring the rod back and start the puddle. Maintain a uniform arc gap with the amperage set high enough to let the puddle spread out. The molten metal follows the heat. Make sure you're filling in along the edges to avoid undercut. Add a little extra metal to the puddle before pulling out back over the weld. You should always examine the finished weld bead for any defects, but really, you need to see the weld as it's going in. This is a totally manual process. You have to control the heat and filler metal during the weld by watching and understanding the molten puddle. Look past the rod and the light, focusing directly on the molten pool. Watch the edges and the weld buildup, constantly analyzing how it's flowing out and how fluid it is, making slight adjustments when necessary. The amperage setting, which regulates the amount of current flowing through the rod, is the main control of the heat available to the weld. When the amperage is set too low, the puddle only forms under the rod. Increasing the amperage generates enough heat to form a molten pool. Along with starting to get penetration, this is where you begin to have control of the edges of the puddle and the weld buildup. There isn't an exact amperage setting here. In fact, this is one of those things that welders see differently. Also, as the metal thickness or weld position changes, the amount of heat required will be different. Watch the puddle. You're looking for it to flow out to the sides of the rod. When the amperage is increased more, the molten pool penetrates deeper and spreads. Eventually, the filler metal becomes so fluid and agitated you can no longer control it. Experiment with the amperage setting. For good penetration and smoother welds, you want the amperage set as high as you can while keeping the molten metal from becoming too fluid to handle. Because of the characteristics of the flux coating, the puddle will look different depending on the type of rod you're using. The entire puddle is visible with 6010 or 6011. Slag covers the top rim of 6013, but the molten metal is still visible on the sides, and the puddle should move easily with the rod. With 7018, slag covers the entire puddle, but you still want to see it flowing out to the sides, with the slag solidifying back from the rod. During the weld, the filler metal is actually solidifying underneath while the slag stays molten. In the horizontal or vertical position, the slag can run or drip. Don't let this fool you into thinking the weld is too hot. You'll probably need to experiment more to set the amperage for 7018, but you will get better results running a little to the hot side. Regardless of which rod you use, the amperage only provides the heat. The rod angle determines how fast the metal will heat up. When the rod is held more perpendicular, the molten pool forms and spreads quickly, allowing a faster travel speed to limit penetration on thinner metals, deposit less metal for a smaller weld, or flatten the bead in a bevel. As the rod is angled, some of the heat is taken off the metal. A slower travel speed can be used to build up a crowned weld bead. If the rod is angled too much, the metal won't get hot enough. The molten pool will narrow, the bead will stack up, and you'll lose control of the edges of the puddle. On most weld joints with a good fit-up, you want to maintain a consistent rod angle to produce a uniform weld bead. In some situations, though, you may need to vary the rod angle during the weld. To fill a gap in a weld joint, the rod can be angled more, slowing down to deposit more metal, keeping the build-up uniform, then angled back up to finish the weld. Controlling the rod angle takes a little practice, but you need to stay loose and relax. Whether you're holding the rod up to flatten the bead or angling it to build up weld, you want to travel at a speed that keeps the molten puddle the same size. Watch the puddle. If the travel speed is too fast, the metal doesn't have time to melt, so the puddle narrows. If the travel is too slow, the metal gets hotter and the puddle spreads. Depending on the rod, the filler metal may flatten out or stack up and roll. Always maintain the size of the puddle with the travel speed. Last is the arc gap, which is the distance from the tip of the rod to the metal. Shielded metal arc welding machines use a constant current power source. The amperage is set with the voltage varying to maintain the arc. You want to avoid jamming the rod right down against the metal or long arcing too far, but you can use slight variations in the arc gap to help control the heat and shape the weld. This is difficult to measure, but a medium arc length is used to build up weld. Shortening the arc reduces the heat, cooling down the weld puddle. Try using a shorter arc gap on vertical up with 7018 when you want to build up more weld. Slightly lengthening the arc causes the heat to increase, spreading the puddle out, and is used with a more perpendicular rod angle for making smaller beads or flattening the weld on heavier metal. It is important to be consistent though. Varying the arc gap during the weld changes the heat, making it difficult to maintain a uniform weld puddle. When you start looking at all the aspects of running a weld bead, there are many possibilities. That's why everybody welds a little different. Practice and experiment, trying to make that puddle do what you want it to do. Watch other welders if you get the chance, but in the end, you need to see the weld puddle at the end of your rod and develop a style that works for you. We've been looking at heating the metal to allow the molten pool to penetrate and fuse. All that heat also has an effect on the base metal itself. Metal is made up of groups of atoms bonding together to form grains. When metal is heated past a certain temperature and cooled quickly, smaller grains are formed, making the metal harder. Cooling the metal slowly allows more atoms to bond, forming larger grains, which makes the metal softer. In welding, the metal adjacent to the weld bead becomes hot enough to change the structure of the grains. Because only a relatively small area is heated, the metal cools quickly, forming smaller grains and becoming harder right alongside the weld. Welding also causes the pieces of metal in the joint to draw. Heated metal expands, so during the weld, the molten filler metal is deposited in its maximum expanded state. As it cools, it contracts. When the metal is free to move, it will draw in the direction of the weld. If the pieces being welded are trapped, the molten weld metal still contracts, leaving some residual stress in the metal. There isn't any way to stop this. The metal is going to move. Whenever possible, weld on both sides to reduce the draw, and on pipe or square tubing, use a sequence of welds to help control the draw. Extreme differences in temperature do have a greater effect on the metal. If it's freezing cold, use a torch to heat the metal up a little. Condensation will appear, and just warm it up until the moisture dries. Also, if you are welding on harder, higher carbon steel, which does not handle expansion and contraction very well, a preheat may be necessary to prevent the weld from cracking as it cools. As always, there are a lot of variables, the type of steel and the stress that will be put on the finished product. In most cases, projects are designed so that the stress put on the weld joint does not come anywhere close to the maximum strength of either the metal or the weld. Try to complete the weld once you start it and avoid building up more weld than necessary. When you're finished, let the metal cool slowly. If the metal does break next to the weld, you may need to take a closer look at the thickness of the metal being used and the overall design. Okay, let's take a look at putting two pieces of metal together. The first steps with any type of weld joint are metal preparation and joint fit up. If you're working with new metal, most of the rods can handle the mill scale, which is a dark layer on the surface. Use a grinder to clean any metal that's rusted or painted. Impurities on the surface can cause porosity, lack of fusion, or even interfere with the arc. When you're cutting metal, keep the edges straight and square. If you use a torch, chip or grind off any slag left from the cutting process. During fit-up, use good tacks to hold the pieces together, and if you're leaving a gap, keep it uniform. Irregular gaps in the joint not only take longer to weld, they make it way more difficult than it should be. You can avoid a lot of problems by cleaning the metal and taking your time on fit-up. While there are many variations of weld joints, there is generally considered to be 4 types: butt joints, lap joints, T-joints, and corner joints. On a butt joint, the weld should penetrate deep, with the amount of weld deposit at least equal to the thickness of the metal. For maximum strength, 100% penetration welds are used to completely fuse the edges. On a lap joint, the weld is called a fillet, with the legs coming up and out a distance equal to the thickness of the metal and the weld slightly crowned. A fillet is also used on T-joints, where the edge of one piece is joined to the surface of another. Welding on both sides reduces the amount of weld necessary and overall produces a stronger joint. Corners are joining the edges at an angle, with metal preparation or fit-up allowing for sufficient penetration and weld deposit. Let's start with butt joints, and this can be on plate, flat bar, angle iron, pipe, or square tubing. When the metal is around 1/8 of an inch thick, keep the edges straight and square for a perfect fit. You'll generally get good enough penetration just butting the pieces together, especially if you can weld on both sides or all the way around. On plate or flat bar, tack right on the outside edges to help carry the heat. For square tubing, tack the corners, then weld opposite sides from tack to tack. If you intend to grind the weld off for a smooth finish, you can leave a very slight gap, but keep it uniform. Whenever possible, start at the outside edge and weld towards more metal. In the flat position, hold the rod fairly perpendicular to the metal. You can weld with 60-10 or 60-11 using a circular motion. Turn the amperage down a little, but you're going to have to travel faster to control penetration and avoid burning through. For a smoother finished bead, try 60-13 or a 3/32 70-18 with a side-to-side movement. On a horizontal, hold the rod nearly perpendicular to the weld. Watch the puddle. With 60-10 or 60-11, adjust the travel speed to let the puddle spread out without overheating the metal. Watch the top side to avoid undercutting. With 60-13 or 70-18, try running straight without any rod movement, maintaining a uniform arc gap and travel speed. If you can position the joint, butt welds on 1/8 metal are easier welded vertical down. 1/8 metal is fairly thin for stick rod, so use some practice metal to figure out the amperage and adjust your travel speed. Starting at 3/16 of an inch, you want to bevel the edges to allow for good penetration. Bevels are generally around a 30-degree angle with the top edge straight and a flat spot called the landing on the bottom. Hold the grinder at a slight angle, using the bottom corner of the disc to take off metal. When you have it close, hold the grinder flat to smooth the bevel and straighten the top. On heavier metals, it may be easier to cut the bevel with a torch, then finish it with a grinder. The reason for beveling the edges is to control the puddle deep in the joint. If the bevel isn't wide enough to get the rod into the bottom, you can always take the grinder up on edge, slightly cock, and use the curve of the disc to open the bevel up a little more. A beveled butt weld can be divided into 3 parts. The root, which is the first pass fusing the bottom of the joint, the filler, and the cap. There are several options in fitting up butt joints, and the main difference is how the root pass is welded. The bevel pieces can be fit up with a small gap, allowing the first pass to penetrate as deep as possible. For 100% penetration, either a backup bar is used, with the first pass fusing all 3 pieces, or the metal is fit up with a gap, and the root fuses the bottom edge and actually builds weld on the back side. After the first pass, filling and capping is basically the same, so let's take a closer look at getting the joint started. Anytime you weld in a bevel, you want to hold the rod fairly perpendicular to the metal to flatten the top of the bead. If you angle the rod, the weld bead will crown, leaving slag that may get covered on the next pass. You also want the weld buildup even. Use a grinder to knock down any high spots from stopping and starting. It's a lot easier to keep it uniform with a grinder than to try to fix it with the next weld bead. Also, if the bead does crown in the bevel, use your grinder to knock off the top to avoid trapping slag. Not all welding situations require 100% penetration. That depends on the type of stress placed on the joint. But you always want to bevel the metal, leaving at least a small gap. 60-10 or 60-11 will provide good penetration, and for the first pass are a little easier to deal with in any of the weld positions. You can use a whip or step motion, gouging into the metal for penetration, then pushing the puddle in to fill. Watch both sides to avoid undercutting along the edges. For more weld buildup, try using a modified circular motion, always coming back to the leading edge of the puddle in the bottom of the joint. If you can handle the puddle, you can also use a filler rod. With 60-13 or 70-18, hold the rod fairly perpendicular. Use a slight side-to-side movement and avoid jamming the rod into the sides. Depending on the bevel and gap, you may need to follow the metal to maintain a uniform arc gap. The base metal is getting thicker as you come up the bevel, taking more heat. During the weld, you want to see the edges of the puddle flowing out and tying in on the sides of the bevel. After the first pass, chip the slag, clean it with a brush, and you're ready to fill and cap. If you can get to both sides of the metal, you can weld the backside for a stronger joint. Grind down to clean metal, keeping the depth and width uniform. With the rod angled a little more, slow the travel speed and build up welds slightly wider than the groove and above flush with the surface. Some welding situations require complete penetration for strength. If the pieces being joined do not fit up perfectly, or with some grades of hardened steel that tend to crack on the first pass, a backup bar is used. A V-bevel with a backup bar is also the procedure for structural welding tests. The goal is to melt and fuse the bottom edges of the pieces being joined to the backup bar. Prepare the bevels with slightly less of an angle and a feathered edge. Grind off the mill scale on the backup bar. Only a narrow strip is going to get tied in, and you don't want surface impurities taking the heat. Fit the backup bar tight with around 1/4 inch gap. This type of joint is generally welded all the way with at least a 1/8 70-18, and you have to be able to get the rod all the way to the bottom. Either tack up on the backside, staggering the tacks, or in the bevel. When you tack in the bevel, grind the starts and stops thin. Always keep in mind, along with fusing the pieces at the bottom, you also want the top of the weld relatively flat to avoid trapping slag. In the flat position, hold the rod nearly straight up and down, angled slightly back towards the weld. Keep the arc on the leading edge of the puddle. With a slight side-to-side movement, pay attention to the arc gap. You want to see the edges of the molten pool tying into the sides of the bevel to avoid crowning the bead. When you're using 7018 in a bevel, stay ahead of the weld buildup and slag. If molten slag is pushed in front of the rod, it can interfere with the arc or limit filler metal fusion along the sides. On vertical up welds, you won't have any problems fusing the base metal to the backup bar. You do want to keep the weld bead flat without undercutting along the edges. Keep the rod fairly perpendicular to the metal, angled up slightly. The puddle needs to flow out on the sides for a flat weld bead and to avoid undercutting. Travel up fast enough to keep the metal from overheating, which causes the molten puddle to spill down. You may need to lower the amperage a little, maybe 5 amps or so, but don't lower it too much, as many problems are caused by running too cold on verticals as by running too hot. Remember, the amperage only provides the heat. It's the travel speed, rod angle, and arc gap that determine just how hot the metal is going to get. On overhead butt joints with a backup bar, you don't get to build up quite as much weld bead. With the rod nearly straight up and down, adjust the travel speed to let the puddle spread out without overheating the metal. Most of the problems with overhead come from not controlling the rod. When the tip dances around, varying the arc gap, the amount of heat at the weld is not uniform and focused. Find some way to steady yourself so you can control that rod. Also, if the rod is angled too far back towards the weld, the molten filler metal takes the heat instead of the metal, causing the puddle to drip. Horizontal is generally not used for welding tests, but you often get them in practical situations. Angle the rod up and slightly into the weld. The bottom bevel acts as kind of a landing, helping to hold the weld, so you may be able to use a slight rod movement. Watch the top side and push the puddle up. Set the amperage to allow a fast enough travel speed so the base metals don't overheat, which causes the puddle to become too fluid. Don't try to carry a lot of metal on a horizontal. Just get all the pieces tied together and keep the filler metal from sagging. The last type of route is in a V-beveled open butt joint. We're going to shove a 6010 rod deep into the gap and run a weld bead on the back side of the metal. Preparation and fit up are more critical, so take your time getting the metal ready. The edge of the bevel needs to be straight and square. Grind off all the mill scale on the bottom side. A half-round file works good to clean up the inside of square tubing or pipe. The landing should be uniform. Use a file to knock down any high spots. With a 1/8 6010, I use a 1/16 oxyacetylene welding rod as a spacer with around a 16th landing. The size of the gap and landing can vary a little, but when you figure out what you like, try to keep it consistent for every weld you make. Line up the bottom edges of the metal. With a spacer to adjust the gap, run 1 tack, pushing the rod right down into the gap. Before you finish tacking up, remove the spacer. As tacks cool, they contract and the spacer gets jammed up. So pull the spacer, make sure the gap is uniform, and finish tacking the joint. On heavier pieces, after the first tack, use a small wedge or a screwdriver to keep the gap uniform. Because of the taper, you can remove these after the joint is completely tacked. On square tubing, tack opposite corners. For pipe, opposite sides. Make sure the gap is uniform, straightening when necessary, then put in 2 more tacks. Flat, horizontal, overhead, and vertical down root passes are all done the same way. Grind the edges of the starts and stops thin. Hold the rod perpendicular to the metal. Scratch start right on the tack. Push the rod down into the puddle and start moving. The filler metal will squirt out the back until you hit the thinned out edge of the tack, and it can poke through. Then move as fast as you can keep the gap filling in. If you're not getting all the way through, you will see filler metal squirting out behind the rod, back up in the bevel. Most of the light and sparks will be on the back side, and you're building weld on the back of the metal. You want the amperage relatively high, so try starting about the same place as you'd run flat. If you do open a hole, stop right away, pulling the rod back over the bead. Restart right at the edge and keep going. When you finish the weld, grind the edges thin on both sides of the hole and fill it in. Some welding procedures require a vertical uproot pass, and generally, you'll need to run about 5 amps lower for uphill. The easiest way is to prepare the metal exactly the same, with a uniform narrow gap, shoving the rod in perpendicular and moving up as fast as the gap fills in. Some welders like to thin out the landing a little more, and with a step motion, rip a small keyhole, then fill it in, rip a hole, and fill it in, always keeping the rod deep in the gap. Other welders like to leave a little thicker landing and wider gap, here again using a step motion, laying metal in and making sure it's fusing on the bottom corners. The disadvantage to stepping the root is the possibility of undercutting along the edges on the back side. The advantage is that you actually see the root going in for 100% penetration. Stepping the root uphill also works well when the gap is uneven, with wide or narrow spots. The backside bead should be above flush, with the entire bottom edges of the bevels melted and fused. Any missed spots are called insufficient penetration. If the travel speed was too slow, the bead stacks up on the backside, causing excessive penetration. On the front side, because the rod was jammed right down against the metal, the bead will crown and undercut along both sides. Grind this out to avoid trapping slag. The metal will be thin from grinding, so you need to run another bead called a hot pass to add a little more metal and burn out any slag left behind. With 60-10, try stepping in the hot pass, not gouging quite as deep on the backstroke. Use a faster travel speed so you don't burn through, and watch the sides to avoid undercutting. You can also hot pass with a 332/70/18. Hold the rod fairly perpendicular. Carry the heat on the sides, moving across the center relatively quick. Don't try to build up a lot of weld, and make sure the sides of the puddle flow out so the top of the weld stays flat. Once the bottom of the joint is fused with any of these procedures, you're ready to fill and cap, and you will get better results using 60-13 or 70-18. If the metal isn't too thick, you may be able to finish with one more pass. On heavier metal, when more filler is required, remove all the slag between passes with a chipping hammer and wire brush. This comes with experience, but plan the weld. When several filler passes are required, overlap the edges of the previous beads if possible. The last filler pass should be slightly below flush. Try to leave the top corners of the bevel. With a slight side-to-side movement, pay attention to the arc gap. Don't jam the rod into the sides of the bevel. Keep the rod fairly perpendicular and the puddle flowing out to avoid crowning the bead. You may need to speed up or slow down to control the amount of filler metal deposit, but try to leave the top corners of the bevel. To cap the weld, angle the rod and slow down to build up a crown weld bead. Use the edge of the bevel as a guide to keep the sides of the weld straight. The finished weld should be as thick as the metal, so if you've penetrated deep, the cap only needs to be slightly wider than the bevel and above flush with the surface of the metal. Filling up more weld than you need doesn't add any strength, just takes longer and puts more heat on the metal. If the top of the bevel is too wide to cap with one bead, run 2 or more passes side by side to cap the weld. With a slight side-to-side movement, using the bevel as a guide, keep the outside edge of the first bead straight. Use the inside edge of the bead as a guide for the second pass. Adjust the travel speed and rod movement so the puddle flows out almost to the center of the first bead. The final pass will generally be smaller. Try holding the rod more perpendicular to the metal, running straight. Use a faster travel speed for less weld deposit. On a horizontal, angle the rod up slightly with a medium arc length. Try running straight without any rod movement. The first bead will help hold up the second pass, so hold the rod more perpendicular and travel fast enough to keep the bead from sagging. For the final pass, try angling the rod down slightly. Travel faster for a smaller bead. On verticals, you can either use small beads side by side or run a weave bead. Small beads are easier. Use the edge of the bevel to keep the first pass straight. Run as many beads as it takes, but try to leave the other side of the bevel for a guide to keep the final pass straight. If you're not limited to a maximum bead width by a welding procedure, you can try a weave bead. Start on one side, letting the puddle flow out to cover the edge of the bevel. Cross the center relatively quick to the other side and hesitate until the puddle flows out and covers the edge. Move the rod up a little, then cross, hesitate, move up, and cross. The upward progress is going to be slow, heating the base metal up more, so turn the amperage down a little. Use the edge of the bevel as a guide to keep the sides of the weld straight. For a smooth weld and straight edges, maintain a uniform arc gap and keep the upward progression tight. Weaving makes it possible to build up a lot of metal, but takes some practice to consistently produce a uniform finished weld bead. Whether you're filling or capping, you need to experiment with the amperage, rod angle, and travel speed, learning to control the amount of weld deposit and figuring out just how much metal you can carry without having it sag or drip. With the butt joint, we were joining the edges of the metal. When one piece overlaps the other, it's referred to as a lap joint. The edge, and especially the top corner, is going to get hot and melt faster than the surface, where the heat is being dispersed in all directions. You want to fuse the bottom corner while building up a full fillet with a slightly crowned weld bead. Lap joints can be welded all the way with a fast freeze rod, but the filler rods will produce a smoother finished weld. In the flat position, the weld is called a horizontal fillet, and you have two rod angles to consider, one in relation to the metal and the other to the weld bead itself. In relation to the metal, the rod angle determines the position of the fillet in the joint. The angle in relation to the weld controls the shape of the bead. Holding the rod perpendicular heats the metal quickly, spreading the puddle for a flatter weld. As the rod is angled back, the weld starts to crown. There are a lot of variables. You have to watch the puddle. With 60-10 or 60-11, hold the rod nearly perpendicular to the weld. With the arc on the leading edge, move the puddle into the bottom corner. Push it up to the top edge and bring the rod around to the leading edge. You may need to speed up or slow down to provide the heat, but always bring the arc back to the leading edge to fuse the corner. Watch the puddle flowing out to the top edge and tying in on the bottom. The fast freeze rods provide excellent penetration, but tend to produce a flat or concave weld. Even on thinner metals, it may take a second pass to build up a full fillet. The filler rods build up a smoother weld. Maintain a constant arc gap for a uniform weld bead, adjusting the travel speed and rod angle so the puddle flows out all the way to the top edge. Because the filler metal remains fluid longer, try running straight without any rod movement, keeping the arc on the leading edge of the puddle. On thicker metal, you may not be able to make a full fillet in one pass. You might be able to get it in two passes. The first one smaller and flat, then slowing down to carry more metal and crown the bead on the second pass. It might take 3 or more passes, and on heavy welds, use 70-18 to prevent the bottom beads from cracking. Put the first one in fusing the bottom corner. Chip off all the slag and wire brush the weld. Determine how far out the weld needs to be, and holding the rod straighter up and down, angled slightly back towards the weld, run a bead keeping the outside edge straight. Angle the rod more into the joint and perpendicular to the weld. Then run a second pass filling to the top edge. Overhead fillets really are like flat welds, just more awkward. Angle the rod into the corner with slight adjustments for different thickness metals. Keep the rod nearly perpendicular to the weld. Watch the puddle flowing out to the edge of the lap piece. As long as you keep the filler metal and base metal from overheating, that weld will stay right up there. On vertical lap joints, the outside corner is going to heat up a lot quicker than the surface. For vertical down welds, angle the rod up slightly. Carry the heat on the back piece. Move into the corner, pushing the puddle to the edge, then back out. Adjust the travel speed to stay ahead of the puddle and make sure you're on the leading edge of the puddle to move into the corner. You aren't going to build up a lot of weld on a vertical down, so you'll probably need to run a second pass. Vertical up with 7018 will not only provide a stronger weld, you can also build up more filler metal in one pass. Always keep in mind that 7018 is very sensitive to the arc gap. You don't want to jam the rods into the sides or long arc across the center. Carry the heat on the back piece. As soon as the puddle flows out, move into the corner, letting the filler metal flow to the outside edge, even pulling the rod out a little if necessary to maintain a uniform arc gap. Then back into the corner and across, slowing down to let the puddle flow out. Keep the upward progression tight and use a high enough amperage setting so you don't have to wait for the puddle to tie in. If you have any trouble running an uphill fillet with 7018, try starting out with a 332 diameter welding rod. The smaller puddle is easier to control. You can also try stepping in a downhill pass of 6010 or 6011 first. This not only provides good penetration, it fills in the corner, making it easier to maintain a uniform arc gap for welding uphill. For heavier metal and more weld buildup, you can either stack weld beads side by side or use a weave bead. Lap joints in any position are fairly easy to weld. The outside corner will melt away, especially on thinner metal. If the top edge isn't uniform, hold your grinder flat and skim along the edge to straighten it up. A fillet weld is also used on a T-joint, and this is very similar to a lap weld, except you don't have that outside edge heating up quickly. On a T-joint, the top side of the weld is going to require more heat, so angle the rod into the corner to push the puddle up. If the rod is not angled enough to allow that molten pool to flow out to the top, you may leave undercut. With 6010 or 6011, always bring the arc back to the leading edge to fuse the corner. Angle the rod to push the puddle up. Watch the top side to avoid undercutting. The filler rod, 6013 or better yet 7018, will provide more weld deposit. In the flat position, hold the rod nearly perpendicular to the weld, making sure the molten pool is flowing out both on the top and the bottom. Try running straight, maintaining a uniform arc gap and travel speed. If you need a bigger weld, try using a larger diameter welding rod or stacking up weld beads. Overhead is the same as flat. Hold the rod nearly perpendicular to the weld, angled to push the puddle up. Maintain a uniform arc gap and travel speed, not letting the metal or the weld deposit overheat. For more weld, stack beads from the top down. On a vertical T-joint, downhill is easier. Use a modified circular motion, always coming back to the leading edge, then pushing the puddle out to the sides. Set the amperage high enough so the puddle spreads out and travel fast enough to stay ahead of the molten filler metal. Watch both sides to avoid undercutting along the edges. 7018 uphill will build weld faster. For the first pass deep in the corner, angle the rod up slightly. Pay attention to the arc gap, following the base metals into the corner and along the sides. This is very subtle. It's just a little movement into the corner as you're coming across, but jamming the rod into the sides cools the weld down, and long arcing across the center creates more heat. Most of the problems with running uphill come from not maintaining a consistent amount of heat. When the arc gap varies, the heat varies, making it difficult to adjust the travel speed to keep the filler metal from spilling down. Try to maintain that arc gap. As soon as the puddle flows out to the side, move into the corner and across to the other side. Let the puddle flow out and move back. Set the amperage and adjust the travel speed so you don't have to wait too long on the sides. As you gain experience and physical control of the rod, you can try to carry more metal uphill. But while you're learning to weld, just get that first one deep in the corner, keeping it uniform and avoiding undercut. If you need more weld, maintaining the arc gap on the second pass is a lot easier. Depending on the amperage setting, slow down or hesitate on the sides until the puddle flows out. Move across the center a little quicker and slow down to let the puddle flow out on the other side. Then just side to side, keeping the upward progression tight. For heavier metal and more weld buildup, you can either stack weld beads side by side or use a weave bead. T-joints in any position will draw in the direction of the weld. If you can get to both sides, alternate welding on one side, then the other until you're finished. Last is corner joints. Depending on the weld position and what you want the finished corner to look like, there are choices in preparation and fit up to provide good penetration. One piece can be beveled at a 45-degree angle, opening it up so you can get the rod all the way to the bottom. The beveled edge is going to heat up quicker than the flat. Angle the rod into the joint, making sure the puddle flows out and ties into both pieces. A first pass of 60-10 or 60-11 will provide good penetration and is easier to handle in the bottom of the joint. With 70-18, try using a 332 diameter rod for the first pass, especially in the horizontal or vertical weld position. Keep the top of the filler beads flat to avoid trapping slag and leave the top edges as guides for the cap. On thinner metal, you can tack up the pieces without a bevel, then use a grinder to groove the joint. For ornamental type projects, you can grind the weld for a nice square corner. Corners can also be fit up butting the inside edges. For maximum penetration, tack up leaving a small gap. This type of fit up requires less metal preparation, and for ornamental type work, the weld can be polished for a more rounded corner or ground flat for a beveled corner. In the horizontal position, angle the rod into the corner, fairly perpendicular to the weld, and maintain a uniform arc gap. When both pieces are the same thickness, they should heat up evenly and relatively quick. With 70-18, adjust your travel speed so the puddle flows out to the top and bottom edges, but move fast enough to keep the weld deposit from sagging. Because both edges are heating up quickly, the filler metal will be more fluid, limiting the amount of weld buildup you can handle without having it sag. If you need to make 2 passes to fill the joint, run the first one fusing the corner and out to the bottom edge. Use the second pass to fill in the top. On thicker metal, plan the weld, leaving a little of the corners for the final series of passes. In the vertical position, downhill will make a flatter weld and will probably require more than one pass. For vertical up with 70-18, the outside edges are going to melt fast, so try using a smaller diameter rod for better control. Pay attention to the arc gap, following the base metals into the corner and along the sides. Keep moving. You won't have to hesitate at all on the outside edges. On any type of corner joint, you want the amount of weld to equal the thickness of the metal. If you have any concerns about the strength of the joint, you can make a fillet on the inside, but this will tend to draw the pieces in the direction of the weld. Whenever possible, always try to make the outside weld first. Well, I hope I've given you an idea of how to put 2 pieces of metal together. There are many more options in metal preparation and fit up to provide for penetration, limit the effects of the metal drawing, and reduce the amount of filler metal deposit. Regardless of the type of weld joint you're working on, you need to experiment with the amperage, rod angle, and travel speed, learning to control the amount of weld deposit and figuring out just how much metal you can carry without having it sag or drip. Make slight adjustments in the travel speed when necessary to maintain the puddle and use the rod angle to control the shape of the weld buildup. Focus on the weld puddle, watching the sides tie in and keeping the filler metal from overheating. Above all else, take your time, have fun with this, and work safely.